Hello, welcome back again to the channel. On this video, we're gonna discuss the following problem. The problem is taken from Baby Rudin, Principle of Analysis, Chapter 1, Problem 1. If R is rational, R not equal to 0, and X is irrational, prove that R plus X and R times X are irrational. Okay, so the way we approach this problem is by asking, what's wrong if they are rational, right? So then we will argue by contradiction. Suppose on the contrary that R plus X is rational. Then R plus X is equal to Q for some Q in Q, where the big Q is the field of rational number. It follows that R is equal to Q minus, should be X. X is equal to Q minus R. And this is in Q, since Q is closed under addition. Okay. Then, but this is a contradiction. But this contradicts the fact that X is irrational. Okay, so therefore R plus X cannot be rational. Thus, R plus X is rational. Okay, and for R times X, it is similar. The proof is very closely resemble the proof above, so then it is a good place for you to practice the problem. So you may pause the video, right, just to make sure that you understand how the argument above was being formed. Okay, let's discuss the second part as well. So for the second part, similarly, suppose Rx is the conclusion is that R plus X is irrational, right? Suppose Rx is rational, then what can be wrong when Rx is rational? Okay, then Rx is equal to S in Q. Since R is not equal to 0 in the field Q, R inverse exists in Q. Okay. Now if we multiply this equation by R inverse, multiplying Rx equal S by R inverse, we get X equals to R inverse S, which is in Q, since Q is closed under multiplication. Under multiplication. Okay, but that contradicts the fact that X was irrational. but x is irrational. Contradiction. Hence, Rx is rational. Is irrational. I'm sorry, again, I made the same mistake as above. So in the beginning, we are supposing that Rx is rational, but then using that assumption, we get into a trouble, we get a contradiction. Therefore, the original assumption must be wrong, which means that Rx have to be an irrational number. Is irrational. Okay, so that's all. Problem number 1, chapter 1. It's not that hard. Okay, thank you for watching. See you again on the next video. Bye bye.